Right, 2.2, still continuing with Free State Preliminary Exam 2024 paper on Physical Sciences. So 2.2 says a learner wants to determine the coefficients of both static and kinetic frictional force between a flat wooden plank and a block. Right, then they are saying he places a block of mass M. All right, let me do this. Okay, right, so they are saying that he places a block of mass M on the wooden plank that lies on the flat horizontal surface as shown on the diagram below. He then gradually raises one end of the plank, okay, and then when the wooden plank reaches an angle of 30 degrees with the horizontal, the block starts to slip and then slides 2.5 meters down the plank for 4 seconds at a constant acceleration. So that is happening after, right? So there's a before and then there's a part of after. Okay, let's see. All right, so 2.2.1 define static frictional force in weights. When we define static frictional force, we are saying this is the force that is acting parallel, right? That is acting parallel to the surface, and it opposes the tendency of motion of a stationary object relative to the surface. It is the force acting parallel to the surface and opposes the tendency of motion of a stationary object relative to the surface. So in other words, it resists the motion of an object. All right, that is for 2 marks. And then 2.2.2, draw a free body diagram and identify all the forces acting on the block just before it slides down the wooden plank. So just before it slides, it was experiencing a static frictional force, right? But after it slides down, it then experiences kinetic frictional force. Okay, so let's try to draw the free body diagram there. 2.2.2. Let's try to draw a free body diagram. Please ensure that you use a ruler. Ensure that all your lines touches your free body, right? So there is, of course, a FG, which is force of gravity, gravitational force, right? And there is also, because this is in incline, so your forces, normal force, Fs in this case must tilt, right? So this is Fs, right? So sorry for that bad handwriting, but then this is Fs, and this is a small letter F and then a small letter S, right? Because you can be penalized for writing the capital letters again, right? The capital letter is only here, Fg, right, with small letter G. And then there is also a normal force, a normal force, a normal force. But because of we are dealing with the incline, please don't forget that, okay, we don't include these forces if we included Fg, right? If we included Fg, we don't have to include these forces. Remember, if there is incline plane, then there will be the component of Fg, right, which is, in this case, it's weight parallel, and then in this side that is weight perpendicular. But we don't have to include this in our free body diagram as long as we included Fg. If you want to include FG, you can therefore include weight parallel and weight perpendicular. But I recommend you to always use free body diagram whereby you included FG, right? Yes, so FG, FS, and normal force. So I've just included this to try and maybe in the calculations to make things simple, right? So let's see the next question. It says that, let's see, 2.2.3, calculate the coefficient of static frictional force between the plank and the block before the plank is tilted. Remember, before the plank is tilted, acceleration is equals to 0 because now the block is not even moving, right? So acceleration is equals to 0. So before, acceleration is equals to 0, but after, acceleration is therefore constant. So it's 2.2.3. We are going to say F net is equals to 0. F net is equals to how much? 0. Right, so let's see. Because now we are looking for the coefficient of static frictional force, we need to focus on the horizontal forces only, right? We need to focus on the horizontal forces. This is the importance of free body diagram. You need to be able to draw free body diagram because it's there, it's very important, and it's going to help you to see which forces are you dealing with and the direction of the forces, right? So because now we want the coefficient of this force Fs, which is static frictional force, it means we need to focus on the parallel forces, right? So the parallel forces, the horizontal forces, it's Fs and also W parallel, but you need to choose the direction. So I'll just say Fs is positive and W parallel is negative. So let's do that. So I'm gonna say Fs, right, minus weight parallel is equals to 0, right? Is equals to 0, and then we know that Fs is equals to the coefficient of static frictional force multiplied by the normal force, right? Minus W parallel, when we manipulate it, it's going to be equals to mg sine of theta, sine of theta, right? Sine of theta, okay? That is W parallel is mg multiplied by sine theta. So let's see now. We do not have the coefficient, that's what we are trying to look for, and then we do not have normal force, but we can try to find normal force because from our free body diagram, normal force is equals to weight perpendicular. So normal force is equals to weight perpendicular, and weight perpendicular is equals to mg cos of theta. Is equals to how much? Mg cos of theta. So let's try to substitute that. So we're going to say the coefficient of static frictional force multiplied by mg cos of theta. Where does this come from? It comes from weight perpendicular, which is equivalent to the normal force, and then minus mg sine of theta, right? Therefore we can substitute. Let's try to substitute there. We do not have the coefficient, so we are continuing writing the coefficient of static frictional force. I think we don't have mass also. Yes, we are not given mass, so we're still gonna say multiply by m, multiply by m, multiply by G, remember G is acceleration due to gravity, which is constant, and that is equals to 9,8 sine of it's cos, rather it's not sine, so it's cos of how much? What is our angle? What is our angle there? That is 30 degrees, right? It's 30 degrees. So let's substitute 30 degrees there, and then minus, we are now on weight parallel. We are now here, right? M, we don't have M. G is 9,8 sine of theta, which is 30 degrees. So we're going to write M multiply by 9,8 sine of 30 degrees, which is equals to 0. Right, so we can therefore do our calculations. That is equals to 0 there, ne? Yes, equals to 0. So let's multiply 9,8 multiplied by cos 30 degrees. 9,8 multiplied by cos 30 degrees. This is equals to it's going to be, let's say 8,487. Yes, 8,487. Yes. The coefficient of static frictional force multiplied by the mass minus, then let's see here, 9,8 multiplied by sine of 30 degrees. This is equals to minus 4,9. It's minus 4,9 sine of oh, there's M there, there's M, right? Yeah, it's like this. Yes, no sine, because I said 9,8 multiplied by sine of 30 degrees, and it's giving me 4,9. Yes, and then there is also mass there, which is equals to 0. Therefore, how can we try to deal with this? Because we've got two unknowns, it's static frictional force and also M. Let's take M as a common factor. So it's going to be M into 8,4, right? The coefficient of static frictional force minus 4,9. And then if we divide by M on both sides, we now divide by M on both sides, we are going to be left with 8,4, right? 8,4 coefficient of static frictional force minus 4,9 is equals to 0, right? Is it 8,4 or is it, let's verify that. I don't know now why do I take, it's 8,487. 8,487. Yes, sorry about that. So please just write 8,487 there, right? And then also here is 8,487. Yes. And therefore let's transpose this to that side. It becomes 8,487. The coefficient of kinetic frictional, or in fact static frictional force, 4,9. Therefore we can divide by 8,487 on both sides. 8,487 on both sides. So it's going to be 4,9 divided by 8,487, and therefore our coefficient of static frictional force is definitely equals to 0,58. No unit, right? It does not have unit because it's a ratio, right? Therefore for 5 marks, oh, okay, it's a lot of marks. So they are saying calculate the coefficient of kinetic friction between the block and the plate. So someone might get confused here. Remember, we said before the plank is tilted, we do not have acceleration. Acceleration is equal to 0. But now we are trying to find the coefficient of kinetic. Okay, which means we need to focus when the block is now sliding down, right? So it means it now has what? It now has acceleration, right? But we don't know that acceleration. We definitely need to calculate that acceleration. So let's try to go back to the information that is given to us and check the information. Okay, so we have a distance here. We have a displacement 2.5 meters down the plank for 4 seconds, right? And a constant acceleration, yes. So now how can we try to calculate acceleration? We have a distance and a constant acceleration, right? So how can we try to find the acceleration? Okay, maybe we can think about the equations of motion. We have 5 equations of motion, right? So let me try to write them all down. So we have Vf is equals to Vi plus A delta T. We also have Vf squared is equals to Vi squared plus 2A delta delta Y, right? Delta Y, right? And then we also have delta Y is equals to Vi plus half, right, plus half A delta T squared. And then we have delta Y is equals to Vi plus Vf all over 2 multiplied by delta T. So which equation of motion can we use? Remember, we have delta X and we also have delta T, right? We do not have final velocity, but we have initial velocity because the block was not moving initial. So it means initial velocity is equals to 0, right? This is not it's delta T here, yes. So it's delta Y is equals to Vi multiplied by delta T plus half A delta T squared. So remember, the block was not moving initially, right? It was not moving. So it means Vi is equals to 0. So which equation of motion can we use in order to try and find acceleration that was constant after the block slides down? So we can therefore use this one. We can use the third one, the third equation, because we have the displacement, we also have Vi, which is 0, we also have delta T, right? So let's try to write it down. So we're going to say delta X, because we are dealing with displacement, is equals to Vi delta T plus half A delta T squared, right? Then we can therefore substitute what is V or what is delta X. Let's go back. Our delta X, which is displacement, is equals to 2.5 and then 4 seconds, that is our time. So let's substitute, right? So this is 2.5 delta Vi, which is initial velocity, is equals to 0, right? And then delta T is 4 seconds, right? Plus half acceleration, that's what we are looking for, and then delta T squared, that is 4 squared, right? Then let's do the calculation. So this is 2.5 is equals to 0 multiplied by 4 is 0 plus half A, it's half A, and then 4 squared is 16. So 16, let us just say 16 multiplied by half, right? 16 multiplied by half is 8, so it's going to be 8A. Therefore we can 0 plus 8A, that is 8A, so we can therefore divide by 8 on both sides. Our A will be equals to 2,5 divided by 8. Acceleration is therefore equals to 0,3, right? 0,312 meters per second squared. That is our acceleration. Therefore, remember the question. Let's go back to the question. The question did not want acceleration, but we needed acceleration in order to find the coefficient of the kinetic frictional force, right? So we will do the same approach as 2.2.3, but now the difference is that we now have acceleration. We are now dealing with acceleration. Remember here 2.2.3 we did not have acceleration, right? So now we use our free body diagram, right? But we now have Fk instead of Fs. We now have Fk instead of Fs. So let's do that. So it's going to be F net is equals to ma, right? Why are we saying ma? Because now there is acceleration, but don't forget that we don't have mass. But don't be scared, don't panic. As long as you are doing the right things, then it's fine. So I chose Fk as positive, right? Although it opposes the motion of an object. So let's do it. Fs minus W parallel is equals to ma. Right. Why are we saying Fs now? It's Fk. Sorry, good people, it's Fk. Yes, that is Fk there. Right, my bad. Fk. So Fk, when we manipulate it, is going to be equals to the coefficient of kinetic frictional force multiplied by normal force minus weight parallel. We said this is equals to mg sine of theta, right, which is equals to mass multiplied by acceleration. Let's try to manipulate n. Remember normal force, we said it is equals to weight perpendicular, right? So it's going to be kinetic frictional force multiplied by weight perpendicular, and remember weight perpendicular is equals to mg cos of theta, right, minus you need to write minus, yes, mg sine theta, which is equals to ma. Therefore we can substitute what needs to be substituted. So we are looking for the coefficient of kinetic frictional force, so we don't do anything with that but write it like that. So it's coefficient of kinetic frictional force, right, multiply by what? Let's see, multiply by m, remember we don't have mass, multiply by g, which is 9,8 sine of 30 degrees minus what? Let's see, minus what? Minus m multiplied by 9,8. Oh, it's cos here. Why do I love sine? Seems like I'm in love with sine, but that's okay. Cos of 30 degrees minus m multiplied by 9,8. Now sine of it's sine of 30 degrees there, sorry, sine of 30 degrees there, right? And this is all going to be equals to ma. Remember we don't have m, but we do have acceleration, which we calculated it to be 0,3125. So let's try to substitute it. So it's going to be 0,3125 m, right? It's m. Right, so good people, let's do our calculations. 9,8 multiplied by cos of 30 degrees. This is giving us we are going to say mu k, which is the coefficient of kinetic frictional force, multiplied by m 8 comma 4, this is 8 comma 487, right, minus 9 comma 8 multiplied by sine of 30 degrees. Now sine of 30 degrees, this is equals to minus 4 comma 9 m, which is equals to 0 comma 3125 m. That is 0 comma 3125 m. Then you can take this, because this and this like terms, right? This and this 4,9 and 0,3125, those are the like terms. So we can therefore transpose this 4,9, bring it to the other side. So it's going to be mu k multiplied by m multiplied by 0,4. Oh, it's 0, it's not 0, but it's m multiplied by 8 comma 487 is equals to, let's add now, 0,3125 plus, right, it's going to be positive when we transpose it to that side. So it's going to be plus 4,9. This is equals to 5,2125 m. Therefore, remember we are looking for the coefficient of kinetic frictional force. So we can therefore divide by m8 comma 487, right? We do have something like this, right? Let me try to show you on the new page. We have something like this: uk, not u, but mu k multiplied by m multiplied by 8 comma 487 is equals to 5,2125 m, right? So what I'm trying to say is that because we want the coefficient of kinetic frictional force, we need to divide by m 8 comma 487 8. Okay, we can say m 8 comma 487. Therefore this will cancel this. We will be left with coefficient of kinetic frictional force is equals to m is going to cancel m. Hence I said, do not panic about that unknown mass, right? So now we divide 5,2125 by 8 comma 487. Yes, that is for the 487. Then this is going to give us how much? 0,61, and that is the coefficient of kinetic frictional force. Okay, all right, interesting. And then the last question, which is saying draw a labeled graph showing the relationship between the force applied and the frictional force. So when you're talking about frictional force, obviously you have to include things like static frictional force and also kinetic frictional force. Right, so what is the relationship between the force applied and the kinetic frictional force and also the static frictional force? Let's represent this graphically because that's what they want, right? So it's 2.2.5. So now force applied is independent, so we are going to say force applied here, right? And then here will be the frictional force in newtons, and also here in newtons, right? So now think about it. If the object is not moving, then you are trying to push that object, it is now going to move, right? So it's going to move because you applied maybe a push force. Yes, push force. So what is the relationship between force applied and static frictional force? Directly proportional, right? Directly proportional, because when you increase force applied, then you will increase the static frictional force, hence the object will move, right? So maybe graphically we will have something like this. Force applied, okay, let's start it here. Force applied is going to increase when you increase force applied, therefore you will increase. Oh man, I can't draw this accurately, right? So I'm trying to draw an increasing straight line, and therefore let's think about it. This is for Fs, right? Fs, static frictional force. Let's think about it now. For kinetic frictional force, kinetic frictional force when the object is moving, when the object is in motion, therefore the kinetic frictional force takes over. So kinetic frictional force is independent of force applied. Okay, it's independent. In other words, force applied does not influence kinetic frictional force. So it is going to be constant. Kinetic frictional force, even when you decrease or when you increase force applied. So your graph must somehow look like this. Okay, yes, it must somehow look like this. And that was question 2.2, Newton's laws, right?